I am Shweta Shakya, and for the assignment of machine learning, I'm doing analyzing and classifying stroke diseases using machine learning. Here we are importing necessary libraries like pandas, numpy, and so on, and then reading the data from the dataset. The data was taken from Kaggle and it is called stroke prediction datasets, where it contains ID, gender, and all the information of the patients. Here are the 10 top columns of the datasets, and there are like 5,110 data columns and 12 attributes in the datasets, and so there are data types. And we describe use the numerical values of the datasets. Here is a box plot of age, glucose level, and BMI. And this is the where we find if there are null values in or not. And so there are like 201 null values in BMI, and we use mean imputation to fill up the missing values. As you can see, the value is there are no null values, and this is the distribution of stroke cases. Like we can see that there are more non-stroke cases than stroke cases. This is calls for a class imbalance. And this is box plot of stroke and age and the histogram of all the numerical values. As machine learning needs numerical values to use numerical values, we convert all the categorical values into numerical values like gender, ever married, resident type, and work types, smoking status into binary values 0, 1. And these are the table of the conversion of the values. The correlation, and here is the map of correlation to find if the features are correlated to each other. As we can see that there is a lack of strong correlation between features. And then we train the model. The model train is decision tree classifier, and the data is split into 80 to 20. 80 training data and 20 testing data. Here we can see that now decision tree is predicting 94 of the non-stroke cases correctly, whereas it is lacking in predicting stroke cases. Also, logistic regression. We are also doing it in logistic regression. This is confusing matrix of decision tree, and as for logistic regression, it is also saying that the same as decision tree, but there's a little more prediction in stroke cases. And also for SVM, they're seeing that 94% of the non-stroke cases is being predicted correctly. And as the classes are imbalanced, we use smooth to balance out the classes. Smooth. And the result after smooth for decision tree and logistic regression and the SVM shows that there's not much difference between while for predicting stroke cases before and after smooth. Though logistic regression shows that it has a little more, it predicts better a little more stroke cases than before smooth. And this is the ROC curve of logistic regression. As you can see that before and after smooth, there are only a little bit of difference between them. And also for the decision tree, it's the same. And for the SVM.